Hi everybody, this is Dr. Dago presenting this time split plot design and now happy listening. Well, this is the eighth in the series of my videos on designs of experiments. I intend to avoid as much as possible, as usual anyway, the installation of additional R packages. The split plot design and R is the topic of this presentation. I've been assuming throughout the series that, even now, that my audience are fully aware of the theory concerning the presented design, and that my task reduces to just providing the arrow codes that are reusable and that will automate the statistical analysis. The reference materials remains Cochran and Cox. Well, with respect to the design, in some field experiments, an extra factor is sometimes introduced in an experiment by dividing each plot into a number of parts. The factor may not be arranged for from the start. It may be midway through into the experiment that you think of, I should have paid attention to a particular factor. Sometimes it will be possible to put it in, sometimes it won't be. But we're looking at situations in which it will be possible to do so. For example, if the experiment is planned originally to test a factor A with 5 levels, the division of each plot into halves permits the inclusion of another extra factor B at 2 levels. Within each plot, the 2 levels of B are allotted at random to the 2 subplots. In an experiment on the preparation of chocolate cakes conducted at Iowa State College, 3 recipes for preparing the batter were compared. Recipes 1 and 2 differ in that the chocolate was added at 40 degrees Celsius and 60 degrees Celsius respectively, while recipe 3 contained extra sugar. In addition, 6 baking temperatures were tested. These ranged in 10 degrees Celsius step from 175 to 225 degrees. Now, each time that a mix was made by any recipe, enough batter was prepared for 6 cakes, each of which was baked at different temperatures. Thus, the recipes are the whole unit. They are like the A factor, whole unit treatment, while the baking temperatures are the subunit treatment, the big factor. There are 15 replications, and it will be assumed that these were conducted serially according to a randomized log scheme. That is, one replication was completed before starting the next, so that differences among the replicates represents times differences. A number of measurements were made on the cakes. The measurement presented here is the breaking angle. There's a technique through which you capture the breaking angle. There are some arrangements, but I'll just call it breaking angle, is to tell some properties, hidden properties about the cake. It is customary to compute the analysis of variance on a subunit basis. We'll soon see that what we mean by subunit basis. However, the data is contained in the table 7.5. Next slide. All right. This time around, I try to manage my slide as much as possible so that we can see all there is to be seen about the data and even the output. This data is pretty long. In fact, doing this by hand is Herculean. All right. So replications. In recipe 1, 15 replications. And these are the baking temperatures. That's subtotals. Now, recipe 2 actually starts from here and it comes this far. Okay. And that's recipe 3. 15 times 6. This is 6 times 15. That's 90 each way. 90 in recipe 1, 90 in recipe 2, recipe 1, 90 in recipe 2, and 90 in recipe 3. These are the rep totals. Continue. It starts from here and continues that way down. The grand total 8,673. 8,673. Okay, that's the data. And the codes. Well, with such a large data, you cannot but expect a fairly long code. You know, to breaking angles, that's for the data, this far. And then there are the codes to be sure that it's properly taken like that. It comes this far. Well, after getting here, you give the data frame for the breaking angle. You may want to look to see how R has taken the data. You can now invoke breaking angles. It will show you the data, but I didn't do that here because the thing will be pretty long. But see, if you are rerunning it on your own, it would be better you see what it is like. Now, finally, you give the model. All right, that's the model. Give it to her, after which you now ask her to produce a summary of the model. Summary of the model. The model is for it to construct the analysis of variance. And an output that looks like this will be given. Well, like we said, it will be done to be sectionalized like that. Well, there's not much to be discussed in here because all the mean squares are highly significant. So that's why I didn't bother providing additional probability and T values. They are highly significant. And that's the way it's done. When you rerun it, you will see how it works. Okay. This is the farthest I intend to go in split plot designs, and watch out for the competition of another design next time. Please like, share, and subscribe. Thanks for listening, and then be nameless. Thank you. See you next time when I come up with another